My original video on this topic, that is basics of pandas and data frames, posted on 17 Jan, got over an hour long. So to make it smaller, I am dividing that in two parts. This is the first part of the same video. The second part would be linked at the end of this video and also in the description box and in the comments section. So in the last video on the basics of data frames, we saw how to build a data frame from scratch, how to select rows and columns from a data frame, and how to add or remove new rows or columns. If you would like to watch that video before this one, the link is provided in the description box and pinned in the comments section. Now remember, you would hardly ever need to create a data frame from scratch, but it's good to know how to do it. Mostly, you would be importing CSV or Excel files or reading data directly from some online sources or repository. The process for doing that would be explained at the end of this video. Apart from that, we will also see how to do conditional selections in a data frame using a single or multiple conditions, how to set and reset index, how to work with multi-index data frames, how to deal with missing data, the use of group by object in a Python data frame, concatenation and merge functions to join multiple data frames into one, and some other operations like finding unique values, sorting a data frame, and pivot tables. So let's get started. So we will start by first importing some libraries and then building a data frame from scratch for the further work. So let me start by importing NumPy and Pandas. Import NumPy as NP and Pandas as PD. Next I will import rand_n from numpy.random to generate random numbers for my data frame. So from numpy.random import rand_n, and I will also drop a seed here, np.random.seed101. By using this seed, if you are following the steps as me, you will get the same random numbers. Now let's build our data frame. We'll name it df pd.dataframe. D is capital, press tab. Then we will use the rand_n and will generate a 6 by 2 or 5 by 4. We will use rand_n and generate a 5 by 4 data frame. If you press shift tab and see here, we need data to generate a data frame, and then we need index and we need columns. So for index, I'm going to use a list. I need 5 labels here. I will use characters A, B, C, D and E. And for columns, I will use W, X, Y, Z. Now let's check our data frame. If you would have dropped this seed 101, then you would also get the same random numbers. And so if you are working alongside me, then you should get the same answers as me, and you can match if you are doing it correctly or not. Now let's move on to the conditional selection now. Before we do that, let me show you something. If you use a condition with this data frame, it will return a data frame of boolean values. For example, if we check if df is greater than 0, then for each cell it will return either true or false based on whether that value in the cell is positive or negative based on this condition. Here I ask for greater than 0. Now if you pass this thing within the data frame, then the data frame will return the values in the cell where this condition was true, and where it was false it won't return anything, therefore it will have a null value here. So wherever the value was negative in the original data frame, we got null, and we got the values for all the positive values here. So you will never be using a condition on the entire data frame. Most of the time we will use conditions on a column or row. Depending on the data frame, you'd either use a condition on a column or a row. So for example, let's take this column W here. It's a series. Now let's check for value greater than 0. So it should return a boolean series with trues for all the index where the value is greater than 0 and false for index where value is less than 0. So we got that. Now if you pass this within the data frame, so see this data frame return a new data frame with index for the true values, and where the value was false in the series, it dropped that index. So it will return a data frame with only the index which satisfies this given condition. This is called conditional selection. Now since this is a data frame, you can index any particular row or column from this as well. So let me show you. We have our data frame. Suppose you want to index and select column Y here. So this will return a series again for just that column Y, and the values will match here. In case you want to select multiple column, you will do the same way as we do with our data frame. This entire thing is now the name of a data frame. You can assume it to be that, and then for multiple columns you can pass in a list of the column names. So let's say we want to index column Y and column Z here. So pass in a list for that, and it will return a new data frame with those index. Now you can see here, if you check the type, this is a series and this is a data frame. So if you index only a single column, it will return you a series, and if you index multiple columns by passing a list, it will return you a data frame with just those index. Now we will move on to multiple conditional selection. So here we have put condition in just one column, but what if you want to put conditions in more than one column? Let's say one column has to be greater than 0, but the data in another column has to be greater than 1 as well. So in that case we have two options, and or. These are called logic operators. Logical operators in Python. So what it does is it helps you to select the data based on conditions applied on multiple columns. So this and or here are called logic operators, and returns a true if both given conditions are true, like true and true. If you want to see true and true, it will return true, or returns a true when even one of the conditions is true. So if you check here, true and false, this will return a false because only one condition was true. But if we change this to or, it will return a true. Only one condition has to be true for this to be entire thing to be true. So AND returns the intersection of two conditions, that is values which satisfies both of the conditions should be returned, and OR returns the union of two conditions, that is values which satisfies even one of the conditions should be returned. So let's do that now. Here let's say, so we have our data frame here. You know how to use condition for the single column. Let's say we want W to be greater than 0, so we can pass in df of W greater than 0. This will return the data frame where this column is greater than 0, so it will drop column C. Now if you want to use multiple column, you can put this into a parenthesis and use and or operator and use another condition. So let's say we want y to be greater than 1 as well, which is only one column e. So this should return a data frame with only one column, because for the first condition 4 rows will qualify that a, b, d and e, and for the second condition only one row will qualify e. And because and is intersection of these two, so only e will qualify out of this entire condition. This has to be greater than 1. Now this will return an error. Let's check this. It returns an error which is value error. The truth value of the series is ambiguous. So what's happening here is this condition provided me 4 rows and this condition provided only 1 row. Now AND doesn't know how to compare two series or a series with a scalar or single value. It can only compare two single values, that is true and true. If there is a series of truth and false and another series of truth and false, and we cannot use AND for that, but we have another operator in Python for that, and we can use, rather than AND, we can use ampersand. And now when I run this, it will work. So for this conditional selection, in place of AND we have this ampersand sign, and I will use the same condition here for the OR operator. And for OR you can use a pipe operator. Pipe operator is given directly above the enter key on your keyboard. If you run this, this should return 4 rows. See, we have A, B, C, A, B, D and E. We have A, B, D and E here for column W, which was greater than 0, and for column Y, one row was greater than 1. And because we are using OR operator, which is a union of both, so we will get all 4 rows A, B, D and E. And when we use the AND operator, which was an intersection of the two, then we got only E, as E was common between those two conditions. Now next we will move on to reset index and set index. So we have this index here in the data frame. Let's say you want to reset it back to the default range index, which was 0 to n minus 1 for n rows in a data frame. So if you have n rows in a data frame, the default range index will go from 0 to n minus 1. So the way to do this, we have a method for this. You can use reset index, start typing and press tab. And if you check the signature here, we have a level argument, and then we have drop, in place, and some other arguments given here. Level is used for multi-index data frames, that is when a data frame has more than one row index. We will talk more about these in a while. Next, pass the argument drop as true if you don't want to retain the original index which is inserted in the data frame as a column. By default it is given as false, and in place is used to make permanent changes to the data frame. By default it is given as false so that we don't accidentally change the data frame and lose data. But if you want your changes to be permanent, then you can pass in place as true. So let's run this and see what happened. So our index got converted as 0 to 4 for 5 rows. So this is now a range index, and the original index which we had, that got transferred over to the data frame as a column. If you use drop is equal to true, then it will simply drop this index here. So it will return just the original columns, and the index will get converted from the levels into a range index. Now if you check the df again, it has retained the original levels here. Had we used in place argument and return true for that, then this will be dropped for real, and if we try to use df again, we will get this data frame, but we won't do that for now. So what we will do now is we will move to set index. Now set index is if you have a particular column in your data frame which you want to set as an index here, then we can use the set index method. So we have our data frame. Let's add another column in the data frame. We'll call this states, and I will use the split method here. I will pass in a string and use a split method. This will create a list of 5 values and will append that as a column in the data frame. So these are US states, and let's check RDF here. So now we have got our data frame with a new column which is states, and we will use this column to set as the index now. So you can use the set index method, and here we need to pass in a key which is the column name for the column you want to set as an index. Then again drop is true by default, so that will drop this column, and in place is false, drop is true by default. This will delete the column to be used as new index. So if we use this states column for our index, it will get dropped from the data frame. And if you turn append is equal to true, this will append this column to the existing index. So it will create a multi-index data frame here, and in place is false by default. So let's pass in our states. So now that states column has been converted into an index of this data frame. However, if you recall this data frame, you will get the original data frame back because we didn't use in place is equal to true here. If you do that, we won't get this. Next, we will move on to the multi-index data frames. So for this multi-index data frame, I have some piece of code written here. Let me run this and show you what we have. Multi-index data frame will have more than one level of index. So for example, say we have two values here in this outside list, G1 and G2, and for both G1 and G2 it will be further divided into 1 2 3 1 2 3. So both G1 and G2 will be further divided into 3 rows. So let's see what is outside list. It's a list of 6 elements, G1 G2 G3, sorry, G1 G1 G1, G2 G2 G2. Inside is a list of 1 2 3 1 2 3. Then we use a zip function to zip this list, and we get a zip object at this location. So to check this, we can convert this to a list, and it will return the zip which converts the corresponding elements of this two list into tuples. So the first element of this outside list goes with the first element of the inside list, and it will create a tuple for that. So this returns G1 G1, G1 1, G1 2, G1 3, G2 1, G2 2, G2 3, and we use a list for to put all of these tuples inside a list. Then we created a multi-index from that using from tuples. So let's check this higher index. So we created a multi-index from tuples using this higher index object, which was a list of zip of these two, outside and inside list. So it created a multi-index. You can see it's a one-dimensional array. It has 6 elements: G1 1, G1 2, G1 3, G2 1, G2 2, G2 3. Now we will create a data frame using this index. So df is equal to pd.dataframe, and we will create random numbers here. We will create a 6 by 2 data frame. For index, we will use this higher index object which we created, and for columns we will pass in a list, A and B. So this will be the column names. Let's check our data frame, and it created a data frame which has two levels of index here, G1, G2. Both G1 and G2 are further divided in three rows, 1 2 3 1 2 3. You can check the index name here, index.names, and we don't have any name here, so we can give some name. You can pass in a list of two elements in this format. So let's say for the outside we'll call it group because it starts with G, and for the inside we will use num. And now if you rerun this data frame, so it will return the same data frame with index name which are group for G1, G2 and num for 1 2 3 1 2 3. Now let's show how to index this. For index hierarchy, we will use df.loc with bracket notation. If this is on column axis, you would just use normal bracket notation with df. Calling one level of the index returns the sub data frame. So let's index this. We have our multi-index data frame. Let's see, you want to see data for a column. For column it's simple, you will just index it for the column and it will return a series. That series will have multi-index. So for the series, it's a multi-index series. So if you want to further index G1 or G2, you can pass in G1 and it will return a series, and then you can index it for 1 or 2. However, if you want to index the rows, if you want to index G1 or G2, you can use .loc method and pass in G1, and this will return the inside part of that data frame. So see here, for G1 it will return this portion, for G2 it will return this portion. Now this is a data frame, so you can further index it. Say if you want data in the second row, you can further use .loc method and pass in 2 here. And it will return these values -1.7 and -1.15. However, if you want to index the data frame based on this second level index, let's say you want data for row 1 for both G1 and G2. For that we have a method called cross section. So we have our data frame here, use access method, and there we can pass in the key which is the index level. Then we have axis 0 for rows and 1 for column, and then we have level. For multi-index data frame, for multi-index you would have labels 0 1 2 3, or you can pass in the name of the level as well, so that Python knows in which level you are looking for that key. So let's see this with an example. Let's say I want to index row 1 for both G1 and G2. So I can pass 1 here, but this will return an error. And this error is a key error. See, key error. And it's a key error because it cannot find 1. It is looking to find 1. So what Python did here was, it was looking to find 1 in this outside group or the level 0 index here. It says level none, but by default it is 0. In case of key partially contained in multi-index, indicate which levels are used. Levels can be referred by level or position. So you can use the level here either by group or num, or by positions, which is 0 1 2. It starts from outside as 0 and goes inside. So it starts from outside as 0 and then inside index should be 1. So you can do that here. We'll pass in our level. You can either pass in 1, that will work, or we can pass in the label name as well. So now it will return the rows for this level 1 here, for both G1 and G2. This entire thing is a data frame as well. If you want to select this row here using the cross section, you can directly pass in a tuple with G1 and 3. Next, we will move to the missing data here. For the missing data, we have two options. Either we can drop those rows or columns or fill those empty cells with some value. Now there is an entire theory of how those value can be filled. Some use average, some use medium. It really depends on the kind of data you have and the field from which you have that data. So you can Google and read more about it. For now, we are just going to see how to drop those rows and how to fill the value here. So before that, we will create a data frame which has empty cells. Df is equal to pd.dataframe, and what we will do here is we will use a dictionary to create a data frame with empty cells. So A would be first column, and we will use np.nan here for empty cells. For B, we will have 5, then np.nan, then np.nan again. So this will have 2 empty cells. And in the end, we will have column C, and let's say that has all data, that doesn't have any empty cells. Let's check our data frame. So we've created a small data frame where column A has 1 missing value, column B has 2 missing value here. Now we will use drop na. Let's say we have this data frame, you want to drop the rows which has empty cells. You can just use the method drop na and it will return the data frame. It will drop all the rows which has empty cells, and it will return the data frame with the rows which doesn't have any missing data in them. Now if you want to do the same thing for the column, that is you want to drop the column and retain only the columns which doesn't have any missing value, you can pass in uh, a parameter for axis. So let's check the signature here. We have an axis argument which is given 0 as default. 0 is for rows. If you want to drop columns, you would have to turn this to 1. It will drop the columns A and B and return the data frame with only the column C which has no missing values. And there are some other parameters here as well. One of these you should know is thresh parameter, and what this does is it requires that many non-NA values to be retained. So here we have our data frame. We use drop NA to drop the rows. Now let's say we put the thresh value as 2 here. So what this thresh does is it requires that many non-empty cells in a row to be retained in order to be retained. So here both 0 and 1 had at least 2 non-empty cells. So both 0 and 1 got retained and 2 got dropped at it had less than 2 non-empty cells. Now let's say rather than dropping this, you want to fill some value here. So for that we have fill na method. Let's check the signature. We need to put the value which we want to fill there, and then we have other parameters like method, axis and in place here. So for the value parameter, we need to pass in the value which we want to fill the empty cells with, and then we have a parameter called method. There are different kinds of parameters given here. We have backfill. So what it will do is it will take the value from the next row or column and fill the empty cell with that value. Basically, this methods will copy over the same uh, value which is given in the data frame in the other cells in the same row or column, and we can use that same value to fill the empty cells here. Axis is once again 0 for row and 1 for column. So if you want to copy the value from the rows, you can use 0. If you want to copy the value through the column, you can use 1 here. Again, in place, turn this to true if you want to retain the values. So what we'll do here is, let's pass in a value here, and I will pass in a string to show you what it does. So it took all of those NA cells and filled this value here. You can also use different methods to fill this. So let's say we have our first column here. We can use fill NA method, and you can pass in the value for this column, take the mean of this column and fill the empty cell with the mean of the values in the remaining cells of this column. And similarly, you can fill other empty cells in the data frame as well. So we will end the part 1 of this video right here. You can continue with the second half at your own convenience, the link for which will be provided at the end of this video and in the description box and in the comments section. So that's all for this video. Until next time, see ya.